Hello and welcome back to math class in session. Let's check this out. Now this is some tough questions. These are tough. Yes, these are hard. So I've laid out a couple of problems here. We'll do them. What I'm going to do is show basically the outline of the solution. It doesn't show every detail. Some of it's left up for you to do. You're going to have to take your pencil and your paper and hit the space bar to pause the video and check and confirm for yourself that all of this is correct. Let's go ahead with this. A fence is 1.5 meters high and is a meter away from a wall. A ladder must start from the ground and rest on the top of the fence and rest somewhere on the wall as well. Calculate the minimum length of this ladder. So we draw a diagram. There's a diagram. We can see that this is the fence, this is the wall, and it's a meter away, and it's 1.5 meters high, and we want to find the shortest possible ladder that can rest against this fence and touch this wall like that. The minimum length of the ladder. So what we could do is call this part of the distance from this point to this point A, and call this part of the distance B. Traditionally, when we put a variable or a measurement on a diagram, it goes in the middle of what we're measuring. Now, A is in the middle between this point and this point, so we know what it means. Now, this angle here, we'll call it theta, is going to be the same as this angle, because this line, this fence, is parallel to this wall. We got parallel lines, we got F-pattern angles. You've seen that before. So that's why those two angles are the same. Now we can start doing trig. Sine of theta is, well, here it is, opposite over hypotenuse. And so therefore we get B is 1.5 over sine theta, because in this configuration these two swap places. Or, now here's where you can pause the video if you need to, but in this configuration the B and the sine theta swap places. And similarly, A equals 1.0 over cos theta. Pause the video if you need to and do that math for yourself. So we have expressions here. And we're going to build an expression for the thing we're trying to maximize or minimize, and that's the length A plus B. The length A plus B is A, 1.0 over cos, plus B, 1.5 over sine, like this. So this is the expression we're trying to actually minimize. We want the shortest possible ladder. Okay. Now I just rearranged it a bit. I said this is 1 times cos to the negative 1. This is 1.5 times sine to the negative 1. Differentiate. Okay, this is where I'm taking for granted that you know how to differentiate. And we'll set the derivative equal to 0. And if this is 0, this negative term jumps across here, carrying it forward. So now we can cross multiply, and we get tan theta equals the third root of 1.5. How? Well, you see, if we put the cos cubed underneath, we got sine cubed over cos cubed, and that's tan cubed. And so 1.5 equals tan cubed, and so tan, not cubed, is equal to the third root of 1.5. Do the algebra for yourself. And so theta itself is the inverse tan function of 1.1447, because that's what the third root of 1.5 is. And so theta is equal to, well, when you do it on a calculator, the inverse tangent of 1.1447 in radians now, it's got to be in radians, we get this. So we have our theta. And so we can just plug it back in. And so the length is 3.5 meters. Now I know there are some textbooks out there that disagree with this, but I'm pretty sure this is right. So check it, pause it, analyze it, see how I did this. The minimum length of the ladder is 3.5 meters. Let's go backwards. What did I do here? I was priming. I set the derivative equal to 0. I dragged this across, made it positive. Then I cross multiplied, but I did that on the next slide here. Cross multiplied, got this. Divided by cos cubed, I got tan cubed, and then cube root both sides. So just tan theta equals cube root 1.5. And of course, there's this algebra thing where tan steps across the equal sign and becomes inverse tan. And so theta is that many radians. Plugging it all in, and we get our answer. Another problem. Okay, this one. The goal posts in a hockey net are 6 feet apart. A player located right here. Here's a player. I didn't draw a player. A player is 3 feet left of the goal post. Looks like he's right, but if you were the player, you're facing out, so that's left of the net. A player is 3 feet left of the goal post and wants to skate out perpendicular to the goal line. So he wants to skate straight out. So that means this is a right angle right here. And shoot at the net. How far should he skate out in order to maximize the angle? So he wants to maximize his angle. This is the angle that he gets to shoot the puck towards the net, and he wants to skate out x meters. So we want to find an x to maximize this angle theta. This is the goal. Okay, solution. We want to find the x value that maximizes the angle theta. So I wrote it down. It's often good to say things when you're writing a math solution. Okay, now Mr. Pythagoras comes to the rescue. Whoops. Mr. Pythagoras comes to the rescue here. This distance right along here, because of this right angle, is the square root of 3 squared plus x squared. So that will be this. And this distance along here is going to be the square, because it is another right angle triangle. It's a bigger right angle triangle. Is the square root of x squared plus 6 plus 3 here, 9. So x squared plus 9 squared, which is 81. And so we got those distances. And now, from the cosine law in triangle ABC, the cosine law, we have the following. Now, you can take that cosine law and solve it for cos theta. And we can say that cos theta is equal to this squared plus this squared minus 6 squared over 2 times this times this. Great. There's your cosine in terms of x. Well, so what? Let's do some math. I jumped to here. I didn't show all the details, but if you square this, you get x squared plus 9. You square this, you get x squared plus 81. If you square that, you got 36. 9 plus 81 plus 36, or minus 36 is 54, and then you divide by 2, you got this 27. X squared plus x squared is 2x squared, but you divide by 2, you got 1x squared. That's where this x squared plus 27 came from, and the 2 has been divided and canceled away. So this is what we're left with. Well, so what? Consider the graph of the cosine function. This curve, cosine function, is decreasing for all acute theta. It follows from this that if the cosine is minimized, then the angle must be maximized. You want to maximize this? Minimize the cosine. That's what this paragraph is saying, basically. I mean, on the street, you would say, hey, you want the biggest theta? You got to get the smallest cosine. Here's some evidence. I like evidence. Notice, the blue line is the cosine, and this is a cosine curve. This blue line is a cos curve. Now, between 0 and 90 degrees, and theta is between 0 and 90 degrees, as theta grows large, the cos of that angle is getting smaller. So the bigger the theta, the lower that blue line is. So the idea is if you want to maximize theta, we'll minimize the cosine. And we've got an expression for cosine. So we don't have to worry about taking the inverse cos of this expression and oh my god. We just have to minimize the cosine because that will maximize our theta. That's the idea behind this solution. And we already have an expression for cos theta. Let's minimize it. Oh yes, I put these two dots on here. This is 0 degrees and this is 90 degrees. This is 180. So between 0 and 90, because theta is clearly it's between 0 and 90. Okay, let's have a look. What do we do? Well, cos theta is that. I brought this forward, and where did I get this? Well, I multiplied these two together, and I just put the root sign and made it an exponent 1/2. This is algebra. You should be used to it by now. Now what? We're going to differentiate. It's a quotient rule. Top thing prime times the bottom thing minus the bottom thing prime times the top thing over the bottom thing squared. And when you square the 1/2, you got to the 1. That's what all this stuff is. Pause the video, hit the space bar. I differentiated. Now I tidied it up. What did I do? Well, let's take a look. Let's go back for a second. This numerator is two giant terms. It's this term minus this term. Now this term is a term because it's all multiplied together. So it's a big clump of stuff minus a big clump of stuff. Now out of these two clumps of stuff, we can common factor. And what comes out of this is 2x comes out of it, because here is the common factor. Here's the factored version of it. And this is the common factors are to the left of this big square bracket. 2x is common to both of these clumps of stuff, because there's 2x there, and you'll notice that there's a 2 comes out of here, and clearly an x comes out of there. So a 2x comes out of both clumps of stuff, so I put a 2x here. I notice this bracket, x to the 4 plus 90x squared plus 729, is present in both clumps of stuff. So I can take it out, and you always take it out to the lowest exponent that you see. So I took it out to the negative 1/2. Open a square bracket and put the results of dividing. When you divide out the 2x, it's gone from here, this clump of stuff. And when you divide this out, when you divide this out, when you divide out a negative, you have to subtract negative 1/2 from this. That's why there's an exponent 1 there. Now if you doubt it, multiply this in and you'll see that yes, it's this to the exponent positive 1/2. When you multiply powers of the same base, keep the base, add the exponents. And similarly, when you take 2x out of here, what are you left with? You're left with 2x squared plus 90x. Why does this say x squared plus 45 then? Because I took the 1/2 and I multiplied it in. So the 2x, take out 2x, you got 2x squared plus 90x times 1/2. I mean, the half has to be multiplied somewhere. Let's multiply it in here. So this is 2x squared plus 90x times 1/2. That's why that's 1x squared plus 45. And the x has been factored out, and one of those x from the x cubes is gone too. You see how much thought went into this one step? And this got carried along for the ride. Check it and double check it until you know it's right. Next, well, what the heck happened here? Well, I took this negative one and I brought it down, makes it positive, and I added to that, made it 3/2. And I multiplied this out and I performed subtraction. Remember all those expand and simplify exercises you've done in high school? Well, here's where you do it. Expand and simplify, collect like terms. And it becomes 18x squared minus 486. Do it. Don't take my word for it. But I know it's right. Now we'll factor out what comes out of here. Well, an 18 comes out of there. Just take out the 18. I take an 18 out of 486, you got 27. And now we're going to minimize this cosine. So we'll set this derivative equal to 0, which means set this numerator equal to 0, which means x could be 0, which is ridiculous. Or x squared minus 27 could be 0. And if x squared minus 27 equals 0, x equals square root 27. And by golly, you have to skate out square root 27, which is 5.2 feet.